So hi guys, welcome back to my YouTube channel, and today I'm up with the next question of top 150 interview questions of the lead code problems, which is best time to buy and sell the stocks. So let's get started with the question. So we are given an array prices where prices of I is the price of the given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So return the maximum profit that you can achieve from this transaction. If you cannot achieve any profit, return 0. So before moving onto this question, and this is the hottest question while preparing for the interviews, so I request all of you to listen carefully during this video. So let's get started with the approach and intuition of the problem. So we are given an array prices 7, 1, 4, 3, 6 and I was given 5 over here, right? 1. Okay, so we have to return the maximum profit that we can achieve, and the maximum profit is 5 in this case. So, and each value in this array represents the value of the stock on that day, right? That's what our question states. So let me just mark something, like this is the first day, this is the second day, this is the third, fourth, fifth and sixth. We all know that the rule of buying the stock: buy at low and sell at high. That's what we have to implement in this question, but just for one stock, right? That's what the problem states. So what all we can do? So if we have to buy our stock at low and sell it at high, so I think that's very simple to find out buy at low, right? So it means that the day on which the value of the stock is minimum, we can buy it on that day. So I think the probable answer to this is that the day on which we have the minimum value of stock, we will select that day as our minimum, and on that day we will buy our stock, right? So it is 1. And on which day we should sell the stock? I think the answer is 7, right? If we see, because we should buy on second day and sell it on first day. Do you think that I'm saying 7, we should sell, we buy on second and sell it on first day, is it really right? No, it's really a common sense that we will sell that stock obviously in the future, right? Because as mentioned in the question, we have to choose one day to buy, choose day one day for buying and one day for selling, right? So 7 is not our answer. So probably we have to find in these values on which day we will sell, where the value of the stock is at its maximum, right? So the choice is on 5th day, because on this day we have the value of stock as maximum, right? So I think we have, from after viewing this question, we can see that we will choose our elements to be prices of 1 and prices of 4. The day on which we will buy is the second day, and the day on which we will sell our stock is the third day, because in the question we do have a freedom of buying and selling it on any of the day, right? But only the condition that happens is that we will, it's not a condition, it's an obvious thing that we will sell the stock in the future only, right? So that's why. But in order to maximize the profit, what we are actually trying to do, we have to find the selling price which is greater than the buying price. So what does it mean? We have to find the element in the array after we bought the stock. Like what are the all possible elements that, what are all the possible answers that we can have for this one, on which days we can sell. We have to choose from this subarray which I have marked in blue, right? So we have to choose from these values only, and in the amongst these, the one which is maximum, I will sell it on that day only. So that's what the thing is. So it means my buying price is always less than selling price, right? And my selling price should be such that that my selling price should be the maximum of all the elements that exist after my buying price. I think this much clarity after saying this statement, that my selling price should be such that it should be greater than my buying price, and we can't buy and sell the stock on the same day. That's not allowed that's not allowed, as we have already mentioned, that we have to, if we have bought the stock, we have to hold, and then we will sell, and then we can purchase the another stock, right? So we have to choose the selling price from the array in such a way that it should be after my buying price, and it should not be equal to my buying price, right? That's it. So let's get started. So what I will do, so if I suppose that I want to buy, so what we will do, we will basically check the probability of all the elements, of buying, right? So what we will do, we will start from our first element. So what we will do, we'll assume that suppose I buy my stock at day 1. Then what I will do, I will check for each and every selling price which exists after my day 1. Like if I suppose I buy my stock at day 1 for the cost price of 7, for the buying price of 7, I have these many values from which I have to choose that at what point I will make a profit, or at what point I will make the maximum profit, right? So what I will do, I will simply do 1 minus 7 minus 6, a loss, and what I will do, 5 minus 7 minus 2, a loss. No, it's not. 3 minus 7 minus 4, a loss. 6 minus 7 minus 1, again loss. 4 minus 7 minus 3, loss. So it means, simply what I did, I assumed that I will bought my stock on day 1, and I will check for the profits that we can have, right? So it means if I am facing a negative profit, it means I am facing a loss. So it means I will prefer not to buy it on day 1, right? So I will move to the next element. So I will check it for 1. So I will assume, let's assume that I will buy my stock on day 2, right? So what all values I will have after I bought my stock on day 2? I have these 4 values from where I can choose, right? So I'll calculate my profit. 5 minus 1, 4, okay. 3 minus 1, 2, okay. And till this point maximum profit is 4, because 4 is greater amongst 2 and 4, right? So 6 minus 1, 5. So my maximum profit turns out to be 5 at this point. 4 minus 1, 3, right? So in this way I've got my first preference, that on which day I will buy my stock, right? I've got that my least till here at this point is, so my market low at this point is on day 2, right? If I say in terms of stock. So this is my first preference. So let's assume until this point we have a maximum profit of 5, right? So I will so let's assume that I buy my stock on day 3. So what all values will I be left to sell this stock? It's amongst these 3 values, 3, 6, 4. So let's calculate the let's calculate the profit for each of the selling days. 3 minus 5 minus 2, loss. So 3 is not a preferred choice. 6 minus 1, 5, profit of 1, but we already have a value of 5, so we will not consider it. So 4 minus 5 minus 1, it's a loss, so I will not prefer to buy on day 3. So let's move to another day, that is day 4. So let's assume that I buy my stock on day 4. So what all values I can have? So it's 6 minus 3, 3. So 3 is not greater than 5, so I'll continue. So wait a minute. These are the values from which I will calculate my profit for 3. On these days I can sell my stock with value. And 4 minus 3 is 1, which is also less than 5, right? So we are done with this value. So I will not buy my stock on day number 4. So let's talk about day 5. So suppose I want to buy my stock on day 5. So on what all possible days can I sell my stock which I bought on day 5? I can sell it on day 6, right? So what would be my answer? 4 minus 6 minus 2. I have a loss, so I will not buy on day 5. So talking about day 6 now, we can't, so after day 6 we do not have more values in our array, right? So we can't really buy and sell on this day. So for 4, no values. Until this point we have a maximum profit of 5. So while computing all of these possibilities, right, we are taking an element and then checking for all the other subsequent elements. We will actually be doing all of this operation in time complexity of O of n square and space complexity of O of 1, right? Space complexity of O of 1. But the interviewer will not be happy with this solution. Why? Because at each and every point we are taking each and every element and checking all the possibilities. But while buying or selling the stocks, we all know that we must buy at low and sell at high. Selling at high means that we can have max profit, right? That's what the intuition is. So let's copy the array and let's discuss the solution which runs in the time complexity of O of n. 1, 5, 3, 6 and 4. So what I can do in order to check for the bare minimum, I can simply keep a track of my minimum element. What I can do, I can simply keep a track of my minimum element while traversing through the array, right? Since, yeah, so that's what it is. First point, that we can keep a track of minimum element while traversing the array. And second, what we can keep a track of maximum profit that we have while traversing the array, right? So what is the maximum profit? Right, we can update both of these values side by side in our array. That's what we can assume. So let's get started. So what all values can we initialize to minimum element and maximum profit? I think it's good enough to initialize maximum profit to 0, because if we do not encounter any profit as stated in the question, we have to return 0. We don't have to return any negative element, right? So what about the minimum element? So talking about the first element in this array of prices, can we buy and sell the stock on day 1? No. So at any one point I will assume that my minimum element to be prices of 0. That let's assume that my minimum is prices of 0. So if we buy one stock, then only we can assume that, So let's assume our minimum to be 0, because buying and selling it on day 1 is not allowed. So to sell this stock, we have to look into the future days. So what we will do, we will simply start our iteration from 1 to n, right? Because we can not buy and sell on the same day. We can't do that intraday trading, right? I think it's intraday trading only, which we talk in the terms of stock. Yeah, so that is not allowed as per the question. So we have to buy on one day and sell it in future. So let's keep a track of my minimum. So let's keep the track of my profit first. Like, what would be the minimum cost that we will have? So let's assume that my cost for each and every element that I have is, so what is the profit that I will have? So what is the profit that I will have at every point? It will be minus I minus min element, right? And then what I will check whether my profit at this point is the maximum or not. So I will just simply compare it with my max profit, my profit, right? And then what I will, and if my max profit remains same as it is the previous one, so I will check for each and every element that I have whether it's the minimum element that I have encountered till now, like it's the minimum lowest minimum or not. And then we will simply return our answer, max profit. That's what the thing is. I think this might have gone a little bit fast. So let's discuss another algorithm which will help you. So let me just try run this algorithm. Wait. So let's assume my first element to be first day on which I assume to buy my stock is 7, right? But wait, when I traverse, so can I sell my, so let's assume my minimum element to be 7. So when I traverse to the next element in the array, do we see that 7 is greater than 1? Yes. So it means why to buy on day 1? Let's buy the stock on day 2. So what I will do, I will simply update my minimum element to, if my minimum turns out to be greater than the existing element, then what I will do, I will simply update my minimum element to the current element, right? And it means that this element will not really contribute to my answer. Okay, so I got my minimum element and I will continue. And now let's move on to our element which we have got, right? So I've got my minimum as 1, and now I have these bunch of values where I have to find my maximum profit. Okay, so compare 1 with each and every element, right? Since 5 is greater than 1, so what I can do, I can simply check that else if my minimum element is lesser than my price of 5. So what I will do, I will simply check for my profit, that if my profit that is with the minimum element is greater than my max profit, then I will simply update my max profit to prices of I minus min element. Right. So I got my answer till here as, so at this point when I have got my 1, what I will do, I have got my min element to be, I'll write the short form as 1, and my max profit at this point is 4. Okay, so I will continue since I've got some profit from here, so I'll continue over here. So let's talk about 3. So is 3 lesser than 1? No. So my minimum remains as it is. So 3 minus 1 turns out to be 2. Is 2 greater than 4? No. So I will continue. So 3 is not the day on which I will sell my stock. So move on to 6. So is 6, is 1 greater than 6? No. So 6 minus 1 is 5. Is 5 greater than 4? Yes. So I will update my 4 to 5. So I'll update my maximum profit. Okay. So I've got my profit till now. So now move on to next element, that is 4. So 4 is 4 1 greater than 4? No. And 4 minus 1 is 3. Is 3 greater than 5? No. So it means I have got my maximum profit that I will sell on day 1, buy on day 1 and sell it on day 5 as per the algorithm. So now let's code this question. Although I've coded the way in which I told the first one, but yeah, let's code the way in which I've told for the second solution. So let's get started. So let's take a variable n which stores prices dot size, and let me assume my min element to be prices of 0 and my int max profit to be 0, and at the end of the day I have to return my max profit. Right. So I will start from my day 2nd and I will go till the end of the array. What I will compare, if my minimum element is greater than prices of I will simply update my minimum to prices of I, and else if my prices of I, which is my profit minus minimum element, is greater than max profit, then I will simply update my max profit to prices of I minus minimum element. So let's just run the code. So I have got the solution. Let's analyze the time complexity using this algorithm O of n, right? Space complexity, let's analyze it, O of 1. So I think we are good enough with this solution. So I think some of you might be having this doubt that why I have used an else if, because if I would have been using my else condition, because there could have been some conditions like where minimum element is equal to prices of I, or where minimum element is less than prices of I. For that, because in the simply else part, because we use an if else whenever we have whenever we have a boolean type of decision, like either it's a yes or either it's a no, but we use an else if at that point when we have more than when we have to take decisions apart from the one, because see, my minimum element decision entirely depends on my maximum profit. So that's why taking, because of this minimum element, my profit is getting affected, as a result. So that's why I took an else if over here. So else if is basically, if I talk about programming in the code, it is basically used because when one decision actually reflects the result of the another decision. That's why I've used an else if in this code. So I hope that everyone has understood this question, and if you have liked the way I have explained it, please do like and subscribe my channel, and share it with your friends. And if you feel that I've missed something, please do mention it in the comment section. I'll be happy to improve myself. So thanks everyone, and keep watching my videos.